We already know that it will require 10 millimoles of NaOH, and it will produce NaCl aqueous, if we may call it a salt. It is actually aqueous, means Na plus is separate and Cl minus is separate. There is no molecule of this existing in the water. It is Na plus floating, Cl minus floating. Okay. But in a way, we write it as NaCl aqueous. Okay. And 10 millimoles of this will be produced and water will be produced. Okay. So that is called a balancing of the reaction. The basic ratio was 1 reacts with 1 to give one of this and one of this. So one absolute knowledge what you should have is of balancing of a reaction. If you can't balance a reaction, then stoichiometry cannot be done. Okay, is that clear? In a balanced reaction, if you know the amount of any one species, either this one or this one, you know the amount of all others because all of them are tightly bound by a certain ratio. Is that clear? So what will the person who is setting the question do? He will try to give you one of the values in a certain way. Most probably an acid or a base, he will try to give you one of the values in a certain way. Okay. So most of the stories go something like this. That there was a unknown amount of acid. It was reacted with a known amount of base. This is known amount of base you have reacted. So you may think that, oh, it is very easy to figure out the acid. Like over here, if the base was 10 millimoles, then I know the acid also will be 10 millimoles if I know the balance reaction, right? But they will twist the story a little bit because you are not in, say, a class 9 or 10. They will twist the story. They will say that, okay, a known amount of base was used. Okay, maybe 11 millimoles were used or 12 millimoles were used. But it created something which was excess of base. That means salt was there, water was there, and some of the base was excess. It got left over. So now you don't know that out of this 12, how much actually reacted with the acid. Was it 10 which reacted with the acid? Was it 11 which reacted with the acid? Okay, was it 9 which reacted with the acid? In the point. So they give excess of base or excess of acid. That is one of the way they set up the question. Is that clear? Are you getting the point what I'm saying?
Yes, sir.
Okay, I'll again repeat my point. If they give you exact amount of, if they say NaOH was getting used to neutralize HCl and they give you exact amount of NaOH, then you know exact amount of HCl, right? Right? And you have to somehow figure it out. So it is so easy. You write the balance reaction, it is done. But then if they want to complicate the question, they will say that I am giving you the amount of NaOH, which was not exact, which was a bit excess. Now, how much bit excess? How much excess? So the story goes on that this the excess base is reacted with some other acid. Is that clear? Is that clear? So now there are two acids in picture and people may get little confused. Oh, what is happening? But it is quite simple. This excess base is reacting with some other acid, and thankfully most of the normal level questions would be that at this stage they will give you the exact. Okay, and it will create its own salt and all, which is all neutral. Okay. Hmm? And now the question is to figure out how much was this. So can anybody tell me like what will be the process if the story is this? Yes. Anybody?
So if we know the amount of acid that is complete
Name first. Your voice. I can't hear your voice. I can't hear
in the
you.
base, we'll find out.
I can't hear you. Your voice is getting disconnected. Anybody else with a better audio?
So, Tisha,
Yeah, okay.
we
I
know the
hope
amount.
people, I hope people who have got basic issues with titration, they are only today over here. Next, I'm going to do redox in the next class. Today, I will do non-redox. I'm doing a very basic question first, and second one, maybe not that basic, I'll do. Okay, Yatisha.
We know the amount of acid, so we can write the balanced reaction for that, and we'll find out the excess base that has reacted over there. Then we subtract that from the original amount, and we find out how much base took part in the first reaction. So then we can find the answer.
Yeah, absolutely right. So I hope you got the idea, people. So this excess base, maybe it was out of the 12, maybe it was 1 or 2 or 3. It reacts with a certain amount of acid. If you are able to write the balanced reaction between this acid and the base, okay, I'll give you a very easy balanced reaction that 1 reacts with 1. Then you would know that how much of the base was excess. Okay, the exact amount of acid required is suppose 2 millimoles. Then what is the story? The story is that 2 millimoles would have used what? 2 millimoles of base, because 1 uses 1. 2 millimoles of base, right? That means out of the 12 which was added, 10 was used for this, 10 was used for this, and 2 was used for the other reaction. Okay, 10 was used for the first acid and 2 was used for the other acid. So if you know that 10 was used for the first acid, you will again check the balance reaction. And again, suppose the balance reaction is 1 reacts with 1. So the acid was also 10, and you know the answer. Is that clear, guys? Is that clear? Is that clear?
Yes, sir.
Okay.
Yes, sir.
Now, obviously, with the same thing, same concept, the questions can be very difficult to very easy. One, for sure, hardly in any question they will give you the moles, number of moles correctly. How are the ways? What are the different ways they are going to give you the moles? They may give you molarity and volume. Can you calculate the number of moles? Yes, you can, right? Multiply and you'll get it, right? So that's a very common way of giving you the number of moles. They can give you the normality and volume. Okay, so I'm not discussing too much of redox today, but a bit of non-redox also. We can use normality. I'll show you that. And you can get the equivalence, and from equivalence, you can get the number of moles. Okay. Your equivalence is X factor into number of moles. Okay. So when they start loading up the information with things which are not direct, it seems little difficult question. Okay. Like this exact amount when I'm saying, they will not tell you number of moles. They will tell you something in terms of mole fraction or molality or molarity or normality or strength. Is that clear? Among which the most common is these three. Okay, molarity and strength is almost the same thing except for one is in grams per liter, other one is in moles per liter. Okay, is that clear? Is that clear? Formality, molality, all those things are rarely used in a actual real life chemist situation also. So generally in JE and NEET, they try to replicate an actual practical question which they are actually the chemists are doing in the labs. Is that clear, guys?
Yes,
Is
sir.
that clear? So if molarity is given, you will be able to find out the number of moles. I hope so. Okay. Now somebody has to make it even more complicated. What they will do is they will say there was a certain acid, say H2SO4. Okay. And the molarity was very high, say 16 molar. Maybe this also they have given in terms of something else, strength and percentage purity and this and that, and you got it as 16 molar. They'll say from this acid you took out 10 ml. Then you poured water in it, added water, and made this 10 ml as say 200 ml. And from this 200 ml, you are using say a 5 ml for your reaction, what I was talking about. Okay, acid plus base reaction. So you see the main story was over here, acid plus base reaction, but then they are making a long trail and coming to the point. Is that clear? Is that clear? The good part is it is all very easy because the math is not even class 8 level math what you have to do. But then the language is so long that if you are really not into chemistry, you might get confused. Okay? Get the point? So since the topic today is not this part, but it is this part, I'm just going to do this part very fast for you. Okay? How do you do it? You say, okay, 16 molar was 10 ml of 16 molar was taken. You concentrate on number of moles alone. Number of moles is the key. Therefore, the whole concept is called mole concept. Therefore, the guy Arrhenius and all, Avogadro, who figured it out, are real geniuses. Okay, number of moles. Number of moles N will be how much? I took 10 ml of 16. So 16 into 10 millimoles. If you write milliliters and multiply with molarity, you get millimoles. If you take liters and multiply with molarity, you get moles. So you got 160 millimoles. So your I is that, okay, I took a 10 ml and in this 10 ml, I'll just draw it over here. Okay, this is the 10 ml. In this 10 ml, I have 160 millimoles of the acid H2SO4. Right? Now somebody is pouring in water and make it 200 ml. How much of H2SO4? Still 160. Nobody is changing that. Is that clear? Is that clear? Now from there, you are going to take a certain part from the whole solution now. So when you are going to take a certain part, the number of moles is equal to molarity into volume is such a easy and cool formula that you always want to know the molarity. So what is the molarity of the diluted solution? Molarity of the diluted solution is number of moles is still the same. What was earlier? 160. Now the diluted solution is M dash molarity, diluted volume is 200. So now M dash should be how much? M dash is 160 by 200. Is that clear? So your molarity has reduced from 16 to 0.8. Okay, 20 times reduced because you have diluted it 20 times. Okay, get the point? Is that clear? Now, when you do this process, you speak everything in terms of language to you. Okay, don't try to just say numbers and all. And I'm multiplying 16 with 10. You'll say, no, I am finding the number of moles in the 10 ml of solution. It makes a big difference how you speak to yourself about a certain question. Is that clear? It is not math. In math, it is number, and the number may not have a physical meaning to it. In physics and chemistry, those numbers have a physical meaning and you have to speak with those numbers. Is that clear? Is that clear? With a physical sense. Is that clear? So you get the new molarity is a 0.8. Then I'm using 5 ml of the new molarity thing. So how much of moles I have taken out of the acid? The number of moles I have taken out is 0.8 into 5. Okay, so much millimoles, 4 millimoles. Now 4 millimoles is going to react with how much of base and all. Your stoichiometry starts over here. Is that clear, guys? Is that
Yes,
clear?
sir.
So the basic structure is quite simple. Acid reacted with the base. One of it was excess. say base was excess, then that was reacted with some other acid and got neutralized. Information of the last reaction will be given to you. From the last reaction, you have to trail it back to the initial part, and information may not be as straight as so many moles per there. Information may be as much wheeled and hidden like this. That story begins and there was some concentrated acid, and from there 10 ml was taken and it was diluted and this and that. In the point, there's someone who can join this late also, by the way. Is that clear? So shall I give you a question now? First you will try and then I'll do it. Okay. Then we'll go to a little worthwhile question. Okay. Is that clear? So give me one moment. Let me just open a question from somewhere and copy paste it over here. Hey guys, can you see the question?
Yes, sir.
Okay, let me just tell you a few basic things, because after all, it is not only maths, bit of chemistry will be there. But if you say that, oh, what the hell, how could I have known this reaction or that reaction? Be rest assured that in 2 years of learning of physical chemistry, whatever looks strange reactions initially at this stage will be, you will be knowing it over a period of time very easily. Okay. Hmm? So before I tell you what are the reactions over here, because that is not the agenda of the class today. Okay, that's the chemistry part. Agenda of the class is, if you know the reactions, then can you solve it or not? Is that clear? But before I tell you the reactions, can anybody just speak up that what reacts? I'll give you another question. I'll not give you a question, I'll just copy paste a certain question and we'll do the one which I pasted right now. Yeah, anybody? Okay, guys, can you see this question? I'm not going to do this question. I'm just going to discuss how they can just puzzle you in the language. Is that clear? I'm just going to describe this question. Are you all ears? Are you listening?
Yes, sir.
A sample of
Yes, sir.
chalk. Okay, whenever they say a sample of chalk, you just be almost, it is certain that this must be having some impurity. Okay. So when I start reading a question, a sample, okay, I'm not reading the whole question and then coming back. I'm just reading in front of you, okay, as I should be reading. A sample of chalk CaCO3. Okay, I am all very worried right now, very worried, or I'm alert that okay, this may be impure. A certain sample, it may not be pure. Okay, is contaminated. Okay, they're straight away saying it is contaminated. I am happy. Okay, so I'm with the person who is giving the question. Now, contaminated with what? Okay, calcium sulfate. They have written the formula also, calcium sulfate. Good. I have say, hello, I'm in class. Ah. One gram of the solid mixture. Okay, so this is taken, it is powder is taken, is dissolved in 230 ml of, so we have calcium carbonate plus calcium sulfate, of which mostly it is calcium carbonate they are saying, and a little bit of this is there, is dissolved in an acid, meaning to say they are reacting. Okay, they are saying dissolved word, but then like you put your finger in a boiling acid, you're dissolving your finger in the acid. Okay, it is reacting. Okay, it's reacting, it is HCl over here. Is that clear? Is that clear? Okay, so little complicated. Okay, two things are reacting. Now my chemistry knowledge will going to little bit of come in, wherein I'm going to help you out with chemistry knowledge, because you have a cool chapter ionic still remaining, and once you are past that, you know all this what I'm going to say. HCl is, I'm a little suspicious whether HCl is going to react with both of it or not. If I'm too good in stoichiometry, I can read the rest of the question and I can figure out that, okay, with this much of information, things cannot be found out unless until HCl was actually reacting with only one of it. Okay. So if I give you the fact that it reacts, it doesn't react with both of it, otherwise the question becomes unsolvable, then can you tell which one it will react with, guys? Anybody? So you'll say HCl is an acid. It should react with the base, right? Now this is a salt and this is also a salt. Which looks more basic salt to you?
CaCO3.
CO3.
Yeah, so this is closer to being a base. Okay, so this is kind of a puzzle. Okay, little bit of a puzzle kind of thing, and you have to be little adventurous. That okay, let us just guess that it must be reacting with this and not that. Okay, if you are a if you are okay in chemistry, either you are going to react with both of it, or you will say that okay, it will react with only one. You will never react with this and not that. You will never react with calcium sulfate and not calcium carbonate, because calcium carbonate is definitely more basic than calcium sulfate. Why? Because if I see the genesis, then calcium hydroxide reacts with H2CO3, reacts with H2SO4 to give you the two salts like calcium carbonate, calcium sulfate, right? This, in fact, is a mixture of these. A solution of these two is equivalent to this. Now this, how much of a strong base it is, suppose you have no idea that it's a strong base, how much of a strong it is, okay. We know that, okay, calcium is same strength. Here, this one is pretty weak acid, right? Right? This you drink also, right? This is soda, right? It is so weak that you can drink it. Can you drink sulfuric acid? You can, but that will be your last day, right? Get the point? So, I don't get ideas, guys. Okay, I'm just kidding. You don't drink acids and all. So what I'm saying is, what was I saying? I'm saying that this is definitely a more basic, because it is made up of a weak base. It is more basic. Okay. So this is something of a little puzzle what you have to be sure of. And that makes the question more and more dangerous. So easier exams don't make you think so much. Is that clear? So 1 gram of the solid mixture is dissolved in 230 ml of HCl. So I would be like, wow, I know the amount of HCl. I'm so happy. How much amount of HCl is there? Molarity is 1 by 10. Normality and molarity of HCl is same. Okay. So I'll just change the question for you. It is molarity is 1 by 10. 1 by 10 into 230. I'm so happy that 23 millimoles of HCl is given. Okay. So it can directly give me the answer of how much of calcium carbonate was there because I have the reaction. I will just balance it and I know it. Okay. But then comes the twister. What is the twister? 40 ml of 1 by 10 NaOH is required to neutralize the excess acid. Meaning to say, what is this? 23 ml is 23 millimoles is not the right number at all. It is excess. Are you getting the point, guys?
Yes, sir.
Yeah. So what's the story? Now they will say that this NaOH is required to neutralize the excess acid. Sometimes they use the word exactly and all. Okay. So I know that, okay, the excess, this 23 ml ka jo excess HCl hai, that is reacting with NaOH. And this is my last reaction. So I will start from the last. Start from last. All stoichiometry questions. You start from the last thing what they say. So how much of NaOH? How much of NaOH? 40 into 40 ml into 1 by 10. How much is that? 4 millimoles. Good for me. Then I'll do a balancing of the reaction. I write the whole reaction, NaCl. I don't have to. If you want, you can. And what is the balancing? 1 reacts with 1, right? So this is given as 4. So this must be how much? 4. 4 millimoles. Is that clear? Is that clear? So out of the 23, 4 is reacting with the excess NOH. So how much must have reacted with this calcium carbonate? How much?
19.
19, right? 4 is gone for this reaction, 19 for this reaction. And here comes your chemistry that, okay, it will be reacting with calcium carbonate alone. So I'll write calcium carbonate. And I'll do a balancing of the reaction. I hope you will get, you know that you'll get a 2 over here and a 1 over there. Right, people? Right, people? Calcium Cl2, CaCl2, it will form. Okay, this is a 2 plus and H is a 1 plus. Okay, so when they're going to double displace, react, then 2 of that is required. React with 1. When you see that 2 plus 1 plus and do that way, we say that we are seeing the equivalence. Okay, it is a more, one may say, cooler way of doing the stuff. Okay, but doesn't matter. So what is it? The story was that I had 19. So 19 must have reacted with how much? How much? 9.5, right? Right? So calcium carbonate is 9.5 millimoles. Now they were talking in terms of grams. So we'll just convert to grams. So how many grams? Grams is number of moles into the molar weight. Calcium carbonate has a molar weight of 100. Number of moles was 9.5. So total grams is how much? And that is millimoles divided by 1000. Okay. So grams is how much? Grams is how much? 0.95. I'm really happy that I got less than 1 gram because the whole mixture was 1 gram. Calcium carbonate is coming as less than 1, 0.95. Okay, and they're asking how much is the purity. Obviously 95% is the purity. The remaining 0.05 gram is calcium sulfate. Is that clear? The main point is, this was the main storyline, that there was a reaction, there was an excess, the excess was reacted with the other one, and from that you figure out how much it was. that it is reacting. This is like such a ghisa pita same storyline that they will put the complication of uh, either percentage purity, or they will put the complication of diluting an acid and this and that, something they will do. Okay. Hmm? Is that clear? So now you try yourself one. If you are able to do this, then we'll do a little better one. Okay. I don't think we have time for a better one. So we'll end it at this. So today remains like a very basic titration class. Next will be little higher level. And after that will be a true equivalence. Okay, which is quite cool. So everybody give it a try. This question, sodium carbonate, is it a basic salt or acidic salt? It is again like a base. Why? Because it is a NaOH plus H2CO3, right? So NaOH is quite strong base and H2CO3 is very weak acid. So it is.
Acid. So it is.
Who's this now?
Who's this now?
Everybody mute yourself.
Everybody mute yourselves.
Okay, do the question. If you have any doubts, you ask me. If there was anything, the previous one I told very fast because that was just I wanted to show. This is we are going to
This
do it
is we are
very
going to do it
slowly.
very slowly.
Here I can
Here
just
I can just
hear
hear
myself.
as well.
Mute
So
yourself.
you mute yourself.
Mayor, please mute
Mayor,
yourself.
please mute yourself.
Yeah, if you have anything to ask, either you change your device or call me. 97420856668. You can call me, Mr. Mihir. Okay, others should be doing the question. So first thing is planning that what is happening. Okay, if you are able to figure out what is happening, I think 50% of the question is solved. The math part is very easy. Make nice diagrams to make everything visually in front of you. I used to make bubbles for everything, round bubbles, and used to write data in that. I will do the same way for solving this question. I'll start solving in 5 minutes, not in 5 minutes, in 2 or 3 minutes. Last line says calcium percentage purity. That is not calcium, it is calculate. Okay. Yes, guys. Anybody with any answer? Anybody?
79.9%.
I don't know. Maybe. No, it is not. I mean, the answer they have given from where I've taken the question, it says something else. Okay.
So is it 90.1%?
Yeah, it says that. Okay, so we'll start doing it. Okay. Hmm? Yeah, so 1 gram of impure Na2CO3. Okay, so we already know that we have impure Na2CO3. Okay, so I don't have to make any drawing right now for it. It has registered in my head that there is some powder of Na2CO3 over there, which is impure. It dissolved in water and the solution is made up to 250 ml. Okay, well and good, 250 ml is there. You could have made it into 500 ml. Who cares how much of it is there in it? 1 gram of Na2CO3. I almost know the number of moles, but then I don't. Why? Because it is impure. If it was pure, then the number of moles would have been, anybody? The number of moles would have been 1 gram by the molar weight of Na2CO3, right? 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 Na2CO3 would be, I think, 106, right?
Yes, sir.
Because I know for sure I used to love this salt because the weight is how much? 100 exactly, calcium carbonate. Okay. So instead of calcium, which is a 40, if I have Na2, which is twice of 23, so that's a 46. So I have 6 extra, so 106. Okay. But any which way, 106, right? So if it was pure salt, the number of moles was 1 divided by 106 moles. Okay. But obviously it's not a pure salt. So this is 1 gram is pretty much useless number. Just for cross verification, it is okay at a certain step. Otherwise, it is pretty much useless and dicey number. Okay. Hmm? So let's continue the story. 250 ml of this solution. That's a basic ploy. Okay, just to increase the length of a question. 250 ml they have made, and they have taken how much? They have taken, sorry, not 20, 50 ml. Okay. So it is like 1/5 that they have taken. So of that 1 gram, how much gram must be over here? How much impure it is? It is evenly distributed in the solution. So your 250 ml had 1 gram of the stuff, right? 50 ml will have how much? 50 ml will have how much? How much? How much? How much? Unitary
200,
method.
200 milligrams. Right?
50 ml will have how much? It will have 1/5 of it, right? Right? 1 divided by 250 into 50, right? 1/5 of the solution will have 1/5 of it. Is that clear? Is that clear? So the story is going to be something like this. Story further, without even reading, you know it, that it is going to be that in 50 ml you are able to figure out how much it is. Then in 250 ml, how much it will be? 5 times of whatever it was in 50 ml, right? Because they are going to do something with the 50 ml. Okay. So to 50 ml of the solution, 50 ml of HCl is added. So I start making my bubbles. Okay. Because we are now in the thick of a story. Now, if I'm not able to keep track, I will start writing it. 50 ml of Na2CO3. Something is added. What is that? HCl is added. HCl is added. Okay. I would always try to nail the number of moles in the bubble. If I know the number of moles, that's the mole concept. That means I know the whole story very well. Okay. So what is it? It is 50 ml of 0.1 molar or normal HCl. Okay. So I know the number of moles. Yeah, I know the number of moles. How much it is? How much it is? 0.1 into 50. How much is that? 5 millimoles. I'm not even reading the question further. Okay, I'm just doing everything till the point, whatever they are giving. I'm absorbing the data. Okay, is added, and I wish it was a full complete reaction. And the mixture after shaking well, fully neutralized, ऐसा कुछ लिखता है, then good for us. But then it is not writing that. It is writing required 10 ml of NaOH extra. So after this reaction happens, it is still requiring what? Another bubble I'll make. NaOH. That means among the two, which was extra? Which was excess?
The acid.
The acid.
HCl.
Why? Because it is requiring a base. Okay. And this train, no, this train can be really long. Earlier, nowadays, there used to be a Roorkee exam. In Roorkee exam, unnecessarily, man, they will make such long question of the same concept as if they just want you to make some error in some step. So required 10 ml of 0.16 molar NaOH. I'm going to write because normality I have not introduced to you. So how many moles of NaOH?
1.6.
How many moles? 1.6 millimoles. Okay. For complete, okay, complete or exact, that's the word. Okay. For complete neutralization, I'm so happy that this is doing a complete neutralization with the acid. Okay, what was the acid? The HCl was the acid. Okay, HCl was the acid, and it is doing a complete neutralization. So in a reaction, if I know one, I know the other. So I'll just write a reaction for myself. NaOH is reacting with HCl. Right, guys? Right, guys?
Yes,
I
sir.
know NaOH. How much? 1.6. I know the balancing. What is the balancing? One NaOH reacts with one HCl. So 1.6 must have reacted with 1.6 millimoles of HCl. So it is reacting with 1.6 millimoles of HCl. So this reaction is actually out of the five, it is how much? 1.6 went over there, and 3.4 is actually reacting, right, guys?
Yes, sir.
So now I'm going to write that reaction. What is that reaction? The reaction is Na2CO3 plus HCl is going to give something, something, something. Okay. I'm going to balance it. I hope you know what is that something. Okay. H2CO3, which you can write as H2O plus CO2 and all. Okay. And NaCl. Okay. So ultimately the balancing will be, you'll have a 2 over here and you'll have a 1 over here. Any doubt? Any doubt?
No, sir.
Okay. So what we know among the two? We know HCl. How much is that? 3.4. So how much is Na2CO3?
1.7.
1.7. So that is pretty much the answer, but then we have to convert to grams and all. So we'll do that. So Na2CO3 in 50 ml, how much ever impure it was, the reaction will always happen with the pure part. So the pure part is in the 50 ml Na2CO3 is equal to 1.7 by 1000 moles into its weight. Okay, I'm not going to do this calculation. You guys can do the calculation. Is that clear? Is that clear? Is it in? It is in 50 ml. So in 250 ml, how much will it be? This is your X. Okay. So Na2CO3 in 250 ml, of which 50 ml was taken and done all the reaction, and 250 ml must have been how much? 1.7 divided by 1000 into 106 into 5, right? Is that clear? And I just pray to God that this number comes less than 1 gram, right? Because it can't be more than 1 gram. Okay. It can add the max be 1 gram. Right, guys? Right, guys? Okay.
Yes.
Yes.
Yes, sir.
Yeah. So,
It comes
how
out to
much is
be
it coming?
0.901.
0.901.
901.
Okay. So many grams are there. What is the percentage purity? Obviously, 90.1% pure. Right, guys?
Yes, sir.
So, pretty basic titration question. Okay. Next class, whenever you tell me, it will be a little advanced, okay, little better than this, okay. And the main challenge will be figuring out the story. The skeleton will almost remain the same. This reacted with this is the ratio, and that reacted with that. The excess of this was taken, it was filtered, and this was taken, and the filtrate was reacted, the powder was reacted, something, they'll keep writing. You keep making the bubbles, okay. You keep following the track, and where the story ends, okay. Generally, the track will be like this. This or this was excess. This excess was reacted with this. And then from that, this was excess. That was reacted with something else. Then that was reacting with something else. Like this. Okay. So much they can go. Okay. Sometimes they are testing your gram conversion. Sometimes they are testing your normality conversion to molarity. Sometimes straight away molarity. Okay. And then this information is given. So you start doing the question from here. You go here, and go here, and go here, and get the answer. Is that clear, guys? Chalo, I have another session at 9. It is already 9:05 with the 12 people. So if anybody has having any doubt in what I've said, you can ask while I admit the other people also.
Sir, Amog had asked something in the chat box.
And you are
Sir, sir,
my
I'm not.
Amog. Amog, can't you speak up? With 2 years of COVID and all kinds of advancement in Google Meet and everything, you don't have a decent mic, or you can't figure out how to have a mic. Guys in my class, don't sit without a mic, okay? Yeah, I'm not reading the chat box. Janvi, either you can tell me the question.
Sir, he was asking, sir, won't NaOH also be needed to neutralize H2CO3 produced in the first reaction?
H2, CO3, no, see, that reaction, good question, okay. Generally, it will be H2O and CO2 bubbles out, okay. And they are specifically saying that it is neutralizing the excess acid, okay. So when they are shaking it, no, all that is going to come naturally. When you shake it, if you are drinking soda, what happens? If you shake it, carbon dioxide goes away, right? So the carbon dioxide is gone away. You have shaken it, and then you are using the remaining to neutralize with NaOH. So only the acid remains. Okay. Good question, not a bad question. Okay. And anybody else? I'll take angular momentum next, or shall I continue with titration next? What is the next thing?
So titration. Titration.
Yes, sir, titration.
By titration, बहुत easy. Angular momentum is the main thing, man. Chalo, next I'll do titration when? Tomorrow is what? Friday? Tomorrow it will be little early because I have to catch a bus in the night. Okay. So I'll send you the time.
Yes, sir. Okay.
Okay.
Yes, sir.
Hello, bye bye. Others have come in my other meeting.
Bye, sir. Thank you.
So
Thank you, sir.
yeah, class 11 guys just drop off. Okay.
Thank you, sir. Bye.
Thank you. Bye. So tomorrow I'll meet at most probably at 7:30 or so. Okay.
Thank you, sir. Bye, sir.
Thank you. Bye.
Thank you, sir.
Class 12, I'm sorry I got delayed. So we are here 1 second, I'll stop the recording.